So welcome to my session about Wasm as the perfect runtime for server-side applications. So let's start off with who's in front of you. My name is Eelco Koster. I work about 20 years of experience in software development, and the last 10 years a lot of working in the cloud and that kind of stuff. And I love working with new technologies like cloud, IE, IoT, and also new technologies like WebAssembly. My work evolves around developing and designing software, and that's a lot of work I do with cloud and DevOps, and most of the time I use .NET technologies. And for the customer I'm working for right now, I'm also using a little bit of Python. So next to my work as a developer, I also do, of course, a little bit of training and like this presentations. I have a small list of customers. There's a few more, but one of my latest customers are here, PGGM, GasUni, NS, and RDW. And most of the time I'm consultancy work, so a lot of time out of the office. I work for a company called Vitas. So this is the last commercial slide, and then we're all going to talk about tech. Vitas, a specialist in Microsoft development, consultancy, and also some in-house development. And we love working with .NET development, front end. We have a UX design team, and most of the time we work with cloud and DevOps. And we have about 70 employees. And of course, like all the IT companies at the moment, we're always searching for good devs. So enough about that. Let's start about the agenda. For this afternoon, I would like to have a small intro about WebAssembly. Then I'm going to talk about why we want to use it, and especially why we want to use it on the server. Then I'm going to talk how we are going to do this, so that's demo time. And at the end, I'm going to talk a little bit about the future of this technology. So let's start off with what is WebAssembly. Who of you is using Blazor at the moment? No, okay, not even half. But okay. So what is WebAssembly, aka Wasm? This is just a short acronym for WebAssembly. It's just the same. So it's meant to bring assembly-like programming to the web. It was first released in March of 2017, and it's built to run pre-compiled code in your web browser. Just not just JavaScript, but you can run code like C, C++, even C#, Rust, Java. Well, you can see it over there. You can have about 40 languages at the moment, which can be compiled to Wasm, and you can run all those code also in a web browser at the moment. And the WebAssembly was also a recommendation from the World Wide Web Consortium a few years ago. So a little bit more detail. What happens is when you have some code built in C++ or C#, that kind of stuff, you can compile it to Wasm, like a component you can see on the screen. And together with some JavaScript and HTML and CSS, of course, you can build a web application with it. But the Wasm code has to run in a sandbox, so it can only have access to JavaScript code, and it doesn't have access to file system or networking or that kind of stuff. If you want to go out of the sandbox, you need JavaScript to do some interaction. So if you want to have some input to the WebAssembly file, or you have some output, you always have to go to JavaScript, and JavaScript can update the DOM of your web page, and then you can do something with it. The advantages of Wasm is that it's very fast. It's a lot of times faster than using the JavaScript in your browser. It's platform independent, of course, because it runs in the browser, and the browser runs almost everywhere in your website. You can see it on an Apple, but you can also see it on a phone, and even all that code which you run in C++ can run on the same systems. And last but certainly not least, it's secure. The code you run in there is just always in that sandbox, and it can't do anything outside of the sandbox. So these advantages are very nice to have in a web browser. But these advantages fast, platform independent, and secure are also very nice to have outside of the browser, because these are just things we want to have everywhere. So in March 2019, a group of people with the Bytecode Alliance, they started to have a new ID, and they have the standardization of the WASI. What is WASI? A system interface to run WebAssembly outside of the web. So WebAssembly can be run just on a server where you want it. And what is WASI? So the WebAssembly system interface is a standard set of APIs that WebAssembly programs can be written to. So you can have an extra set of APIs to access file system, to access network, or access other OS kind of things. And it makes it possible to create truly portable non-web WebAssembly applications, although they also can run in a browser again. But you have some extra capabilities which make it possible to run out of the browser. Why is it important? Well, first of all, if you're talking about WebAssembly on the server, this is one of the slides almost everyone shows. Solomon Hykes is one of the co-founders of Docker, and he tweeted about this. If Wasm and WASI existed in 2008, when he created Docker, it wouldn't have been needed if Wasm and WASI was there. So that's how important it is what he's saying. But this was about 4 years ago, and what he was saying at the end, last sentence, let's hope WASI is up to the task. So now 4 years later, we have some development on this, and I'm going to show you where we're at right now. We also want to show you this website. This is the Cloud Native Computing Foundation, and they have an annual survey. Every year they have they're going to have a questionnaire and ask people about it. And what they're saying is containers are the new normal, and WebAssembly is the future. So, and in the end, over here on there, you can see that almost overall 37% of people are already trying this out. And like it's stated, although many are still just personally testing the waters. And that's something what I'm going to show you also, because this is still a little bit in a testing phase and in a beta phase. So next question, I've talked to some colleagues about it. So okay, you can have this Wasm code run on your server, but why should you really want it? Because C# is also an application which is a little bit platform independent. It's pretty fast, and yeah, we can say it's secure. So what makes this different? And I'm going to show you a little over what's happened normally. So normally if you're going to run some .NET code on your laptop, you're going to build a little console app like Hello World. And if you compile it, they will have the Hello World DLL. It's just a small DLL, and it will have compiled in it EL code, intermediate language code. It's not assembly code, but it's code which has to be a little bit interpreted. It's not like JavaScript totally interpreted, but it's code which still needs to be just in time compiled before you can run it. And if you want to run it on a machine like Windows, Mac OS, or Linux, you need to install the .NET Core runtime. Because without the .NET Core runtime, you can't run this DLL, because normally it doesn't understand the EL code. Since .NET 6, you can also run a .NET code at ahead of time compilation. And this means that it's not only the DLL you compiled with the EL code will be pushed to wherever you want, but you have to compile your application for a different architecture. So you just create different, you compile your code for different architectures, and the architecture or the component you have, like here, is a complete application which can run on that system without extra need for .NET runtimes, that kind of stuff. So it's just native code you can run on the system, but you have to compile it per system. So when we go to WebAssembly, your code is going to be compiled to a .wasm file. And this is a pre-compiled assembly code. It has a very fast startup, and you can just compile it once again, and it can run everywhere. The only thing you need on your host is the Wasm host. But the Wasm host is not like the .NET runtime, something Microsoft have to make, but there are already like 4 or 5 vendors which made a Wasm host, and the Wasm host is not just for .NET code, it's also for C++ code or Java code and that kind of stuff. So there's a broader audience to make Wasm hosts, and they're all widely available already. And one extra thing what .NET code doesn't have, if you just compile or do .NET code, is that the Wasm file, the host will have to give you explicit access to access things like the file system, that kind of stuff. So if you want to run it, you have to explicitly say, okay, you can access the file system, or you can access the network, or that kind of stuff. If you don't do it, you don't have access to it. So in a little bit more detail, so WASI is exposing a typical operating system functions, and it's just something which, almost likely the POSIX for Unix. Everyone knows what POSIX means for Unix, because you have a lot of different type of Unix, and if you want to have your own version of Unix, you should have to build your own applications for that system. But if you have a standard like POSIX, all application that's also defined to the same POSIX kind of stuff, then you can just run these applications. If they both understand POSIX, you can run them there. And the POSIX is just giving you some OS functions like file access, network access, the OS time, that kind of stuff, and also threads, so you can do multiple threads. And like I said before, it's a capability-based security. So users have a user principal has a least privilege, so no access until someone says, now you have access. And once again, over here, WASI is currently experimental. So let's start off with some code and what we can do with it. So developing a WebAssembly app, well, it's very simple actually. So let's just go to a command line, and you can see I have a small demos. But if we create a new demo, can anyone see this in the back? Okay, just make it a little bit bigger. So created a new folder, and I go in there and I do a .NET new console app. It will just create 2 files. It's the project file and a program file with just one line of hello world in it. And if we're gonna run it, well, anyone will show that it will say hello world. Yeah, okay. Took a long time, about 7 seconds. But, well, it compiled it, of course, and then it says hello world. And if we go into the code, of course, you can see only these DLLs, which it will normally produce. But if you want to make it WebAssembly, you just have to add a package. So .NET add package, it's the wasi.sdk, and this is still in pre-release. So if we're gonna add this, you will see that in the project file, it just added one package to the WASI SDK. And when that is added, we can .NET build it again. And what happens right now is that it's bundling all the DLLs which are needed for .NET. And well, this first time it takes approximately 30 seconds. And now we have an extra file within our bin folder, which is a .wasm file. 30 seconds. 22 seconds. A little bit faster. So when I go to the folder again, you see the extra future tag.wasm file. That's the only difference. What was added, and well, I want to show you how big it is. So it's about 8 megabytes is the file right now, so it's a lot bigger because it also has the DLL files. You have a question?
Yes, it is possible to use Wasm or WASI in combination with AOT because it seems like there's no runtime inside the container, or it is always AOT compiled.
So I don't totally understand. You want to use it in IoT? Yeah.
Ahead of time compilation.
Oh yeah, it's always ahead of time compilation. Yeah.
Okay.
Yes, it is ahead of time compilation to an assembly kind of code. Yeah, but because the normal hosts don't have a garbage collection in it at the moment, the compiled files also have a garbage collection of C# in it on top in your Wasm file. So if you want to run this, you can use a runtime like Wasm time, and if you say the future tag, this one, it will say hello world, and it runs the Wasm version of it. So this is just a small thing, and I just wanted to show you that it's possible without any code to very simply create a Wasm file, hello world. But of course, this is a little bit too small. So I'm going back again, and I start a little bit a bigger project, just very small still, but I don't want to type too much code. So I created the hello world, and it's almost the same with just a little bit more code in the program, .cs file. So we go into this one, and we'll close the other one. You can see just a little bit more code, a little bit bigger. So it's just simply stating the same hello world, but it also shows the time, the different architecture it's running on. So that can be an x64, or if it's a Wasm file. And we also created some extra things like we can read a file or we can write to a file. Just very simple, but it gives you some more detail of what's happening within this code. So once again, if I'm gonna build this, because yeah, sorry. It is neat, but yeah, differently. So building this again. Sorry, take some time. Come on. Okay, so we go to the folder. You can see the exe and the Wasm file. So first off, we start the hello world.exe. And if you're going to say, you can see it stated current architecture is x64. It's just a normal exe file. And it also said a file was not found, let's create it. And you can now see that it created a data.txt. So if we type that one, you can see it was a create file within the file was created with the same architecture. So if we're gonna remove this one, and we're gonna now start the WebAssembly version. Hello world. You can see it will give an error. Because if you read it, you can see current architecture it Wasm. file not found, and then it says error. It wanted to create a file, but it doesn't have access to create a file, so it will give you an error. So you explicitly have to give it access to the file system. It can do that pretty easily by adding an extra parameter. Like this gives it access to the local folder. And if you can try it now, it doesn't give the error anymore. And we can type data again, and you can see the file was created with Wasm architecture. So now the file can be created with Wasm. But then again, if we want to read the file like this, you can see also it can read the file. And if we say we remove the access, it will simply state, hey, I can't find the file, so I want to try to create it again, but it can't. But even if the file is there, and we don't give it access to the file system, it can't read that the file is there, so it will think it's not there, and it will try to create it. So these are just simple things, how you can build your code with a little bit of C#, and things like Wasm time host to give some access to a file system. So next demo I'm going to give you is about developing serverless web applications with a tool called Spin. And Spin is a tool by a company called Fermion, and they created some application where you can build serverless applications with WebAssembly. And they also have their own cloud system where you could deploy it, but you can also do this on your own system. So what happens over there? Let's go to my different example. Sorry. And it's called, of course, Spin. And Spin is just, you can oversee spin.exe. I downloaded the application, but it's just one assembly file. It's like a portable exe file which you can just copy around, and you don't have to really install it. You can just have the file, and then you can run your code. So let's see what's happening over here. Let's get that one down. So what I've done over here is also create a .NET Wasm file. It's the same project file with also the package again. And we have a program.cs, which is almost the same as the hello world, because I wanted to just increment in little steps. And over here, the first line I'm extra doing is adding a line for the content type. Because what this happens is with Spin you can just create the output to the console, and the console output will go to your browser. But if it wants to run in a browser, you have to give your browser some extra details, like, hey, what kind of stuff is coming to me? And over here, the first time we're saying, okay, this is text HTML, and because it's text HTML, it can render it as HTML. And then I've almost got the same code as in my earlier project. So it's again stating the time, the architecture, and what I've done here is I can read a file, but what I don't have over here is that it can write a file to file system. That's because Spin is not able to write files to the file system at the moment, or maybe it will never have, but Spin does have some other how do I say it in English? It does have other ways to persist data. So you can still use a MySQL database or that kind of stuff to store data, but you have to use like some Spin way to access the database. But just from your Wasm, you can just access the database directly. So this is just almost the same code, only with the extra content type in front of it. And the other thing I have to specify is a spin.toml file. And this is like the configuration for your function app. And yeah, it's almost, yeah, it looks a little bit like if you're using Azure Functions, because up front is just some configuration that we're using spin. The trigger over here is an HTTP trigger, and you can have define multiple components which you want to access using the web. So here I have a simple component called hello Wasm, the source of the Wasm file that has to run, and well, over here the trigger is root of my website, and the DOS behind it says that everything, it's just from root, and everything behind it will go to this component, and it will trigger this Wasm component. Over here is my extra definition for accessing the file system. So over here I'm just saying, hey, use the local folder, and you can do anything with it. If you don't want to give it special access to the whole folder, you could also say just give access to just the test.txt file, because that's what I'm using in the program. I'm reading the test.txt file, and I will output it. And in the test.txt is just hello tech, future tech. So this is all you have to do to create a little web app. And when we go here, I think I already compiled it, so I can just do spin up. And now I have it running. I go to the website. You can see that it will run. It says hello Wasm, and you can see the same things adjusted. So this is a simple way to just create web apps with Wasm. And you see, this doesn't do really much, but it's really a fast way of creating code, but it's also a pretty fast running code. And again, it can be very secure. So that was an easy demo for just creating a simple web app with Spin. And I want to take it one step further, because for the next thing, I also want to use Kubernetes, because an extra thing with Wasm files is that you don't really need an operating system within your container. The Wasm file can run directly on a system, and you don't really need layers like an operating system, that kind of stuff. So normally you have a Docker image, which is 100, 200 megabytes, and you can now just have this Wasm file of a few megabytes, and it can run in Docker, and it can just also run in Kubernetes. So I want to show that also. And for that, I also started something before this presentation. I've created an Azure Container Registry where we can push our containers to. And I also created an Azure Kubernetes service. And within, if you create a Kubernetes service, you get the first node. So the system node is something you get when you create an AKS service. But the extra one, the WASI user node, is something which is still in beta. Of course, most things are all in beta. And if you want to create it, you can create it using the portal, but you have to use the command line tool. And the little command there on the side is, well, for people familiar with AKS, a pretty normal command, except for the last line. The workload runtime Wasm WASI, that's the new thing. So you have to create an extra node, and on that node you can deploy your Wasm pods and your Wasm code. So it can just run on the normal node, but you have to have a special node where you can run these things. So over here, I got this resource group, and with just these two things. And within the container registry, I have no repositories at the moment. And my demo, I'm gonna stop the spin. And I'm going to the Kubernetes demo. So here, let's open up code again for this demo. So for this, I just kept it very simple for the code in your Wasm file. It's just almost the same as what it's been. So you still need a content type. Well, this is text plain, just giving the text. And after that, you just write some to the console file. And what I've used is just Kubernetes, but in Kubernetes you can use the spin runtime to use the same code. So this is a combination of spin in Kubernetes, which is the runtime, and I'll just containerize my code and push it to the Kubernetes cluster. And the Docker file is very simple. From scratch, it means it doesn't need an OS, it's just a no-op command within a Docker file to say, okay, this is where you can start. And I'll just copy the Wasm file, and I also copy a spin.toml file, because the spin needs that toml file as the configuration. And that's all there is. So the spin.toml is also almost the same as the other one. And well, this is just the code. These two files will be put in my Docker file. So I'm gonna try it here. So I think I already built my file debug. Yes, I over here already got the Wasm file. So when that one is done, I can build it to a Docker file. And I hate to typos. So Docker build, Docker file, and then I'll push it create it for my registry. So if I run this, now it's going very fast because I did this earlier and now it's coming from cache. But now you can see Docker. That you can see the containers I have, and most of them are like gigabytes. But the last one, Eelco Wasm, the spin in KS, is just 8 megabytes of size. Yeah, almost 9 megabytes in size. So it's very small. It's the smallest one in here, except for the last one. I don't know what Hello World is, but it's probably not a big, not a normal container. So I've got it, this container, and if I want to push it, I can now push it to the container registry. And this is going pretty fast. So now I've got this container registry with my container in it in my registry. So now I can push it to my Kubernetes cluster. And let's go back to this. So for this, I have 3 YAML files. First of all, if I want to run this in Kubernetes, we need to assign a runtime class for spin. So this is the runtime. Say if I want to run spin applications within Kubernetes, you need to create the spin runtime. And for this to create cd YAML. So here they are. You can see the Kubernetes ctl get pods. It's now empty. Doesn't have any pods. That has nothing run. So if I want to do this, I can apply the spin runtime, and I can also apply my application, so it will create a pod. So with this code, it will create my container of the Wasm file in Kubernetes. And to run that, we can just do this one. And if we go to this command, get pods, you can see my container is now running in Kubernetes, but you can't exit from outside because every part within it, you have to open it up to the world to see it outside. So to do that, I punch a hole in the load balancer to just say open up port 80 from outside, and then we can use it. So I created a service. So it created a service, SVC. So service is up. It's in the load balancer, but it doesn't have a public IP address already. But now it does have a public IP address. So we go to a browser. Sorry, someone's calling me. If you go to a browser, to that IP address, you can see the Wasm container is now running in Kubernetes. Yes, question?
Do you still have the Wasm file which you can run locally with Wasm time? Or?
Yes, this same file can also be run just locally now. And it's the Wasm file, but this Wasm file is just only packaging the Wasm file and the TOML file, and it's just the things that's needed in a container. But if you just
file, then it's copied into a container.
Yes.
Upload to.
Yeah, it's just an extra step. Well, normally you don't really need you can also run just a Wasm file in a container. If you want to use Docker and don't want to use Spin, or you don't want to use Kubernetes, you can also just use Docker and run it locally. And well, then you just change this Docker file. You have to copy the Wasm file. You don't have to copy the Spin file, of course. Yes, thank you. And then you have to have an entry point to the Wasm file. And if you just start the Docker, then it will start the Wasm file.
And
so.
You can also run it without Docker.
Yes, you can also run it without Docker. Yeah, so the extra need for using Docker is not really big, but you can of course add some extra configuration in it, and you maybe add some extra assets like files or images and push it over in there and give it access to that from the Wasm file. But there isn't a big need for Docker containers anymore. That's right. So that's what Solomon Hykes was saying. If this was developed earlier, we maybe wouldn't even have to invent Docker. Although I think that Docker still have a lot of use for different kind of applications. So it's not that we shouldn't use Docker anymore, but for now, yeah. So this is, question?
You use Spin to set up an HTTP endpoint.
Yes.
Is it also possible, as what I saw, is you can access local file system, you can access network connections, to just run a full-fledged ASP.NET Core application with Kestrel as a Wasm application?
Not at the moment. But yeah, probably in the near future it will be possible. But the network access, there is some network access. But for Spin, when you open up the Spin, it will open up a port for you to be used within Wasm. But for now, you can't open up a port within Wasm. You can just use a port which was already opened by the host. So this is another security thing. But when it's open, you can use it. That is possible. But so there, it's still in pre-release and all in beta. But there are possibilities for in the future. Yeah, I saw a hand over there. No questions more. Okay, then I'm gonna end it off. Where's my presentation? From here? No. I don't see my presentation anymore. We'll probably closed it. Sorry? Check. Thank you. Sorry. Okay. So a little bit about the future. What I'm seeing. So we're still in beta version, and what needs to be done is finalizing more specifications. So just a month ago, they released a specification for threading. So then we can also use some threading within Wasm. It's not possible. Yeah, it's possible now, but it's still not easy possible in C# code. Only in Rust there are some tests. They want to add some garbage collection, native to the Wasm host. So now if we compile C# code, we have to have the garbage collection in our code. But if we can pull it down to the host, we don't have to have a garbage collection in our own code, and then our Wasm files can be even smaller. And another thing is a little bit about outside of the WASI configuration, but they're also opening up the neural network things where we can have a Wasm file which can access the graphical processing unit, so we can have better AI things within Wasm. And another thing I think is very interesting is the last one, is WebAssembly components. And this will make it possible to have C# code combined with other Wasm files. So people can build libraries in Rust, in C++, and that kind of stuff. And we can implement that code within our C# code. So that will give a lot of new possibilities to our code. So that is almost the end of my presentation. I don't know. It's the end for time. Going fast over it, so 3 use cases I see. Serverless is a fast startup time and that kind of stuff, and also let's see with Spin. Another one is that you can have in the future maybe have the Wasm files in SaaS products, because it's a secure sandbox. Your SaaS providers now don't want you to have your own code running within that SaaS product. It's their product. But within the sandbox, SaaS providers might be willing to give you a little bit access just to run your own kind of small pieces of code within the SaaS product. So that's some new capabilities that can come up. And the last one is that we can use user-defined function within databases. And now we have to get all the data from the database over the network, process it, and maybe push it back. When we have the functions close to our data, we can do it a lot faster, and we don't have network access anymore. So that was very fast, because it was at the end of time. Thank you for your attention. If any more questions, then you can notice. Yeah? Yeah. Thank you.